Hello, I'm Jono and I built an automated gardening system inside this shed. Round 2. The prototype proved the concept, but it wasn't good enough. There were some obvious upgrades to make, like insulation, lighting, and structure, and I also got some solid suggestions in the comments in the last video, so I decided to build a better version. Here are a few quick shots from the prototype so you know what I'm talking about. It worked, but it was kinda rough. But just wait until the end of this video because it becomes a completely different shed. And this is where the rebuild started. The first version didn't even have a floor, so I got started on that. I just used a large piece of plywood and put some waterproof paint on it. But before we get any further, let me describe our plan of attack. Phase 1 was to rebuild the structure with the new floor insulation and turn the shed into a controlled environment. Phase 2 was to build the hardware, including sensors, relays, pumps, and lighting, everything physical. Phase 3 was power and control to safely wire the AC loads and let the Arduino handle real-time control. Phase 4 was networking and software, connecting the Arduino to a Raspberry Pi and build a live dashboard and to enable remote access. Then lastly, Phase 5, automation and testing. We wanted to add an AI supervisor to control the environment and validate the system with real plants. And I wasn't alone this time, I had 2 trusty teammates. First here is Lucas, a fellow electrical engineer. And this is James, another fellow electrical engineer. We're all electrical engineers. We'll try to be safer than that because
safety is number one priority.
But no promises. And so with the crew assembled, we began cleaning out the shed and spray foaming all the gaps.
You missed a little spot right there.
Oh yeah. I didn't think we'd do that shit. Yeah, I'm cool. Yeah. Just gotta be real careful.
Is it getting it?
Yeah. It's like I'm holding the camera, bro.
It took a little while, but eventually we got it all sealed up.
Yeah, it's solid, boys.
Then we had to cut 2 big squares into the sides of the shed for the intake and the outtake fans. We didn't really have a good tool for this, so we just drilled a bunch of holes into the wall and cut them with some branch cutters.
تكنولوجيا عايش هدنها تكنولوجيا
Then we had to go pick up some foam insulation from Home Depot, but it didn't quite fit in the car, so we came up with this method.
Actually, we should probably put that chair down more.
Water. Yeah.
And we also decided to move the shed. We tried sanding down the edges of the holes we cut, but that didn't really work out, so we went full Oompa Boonga caveman mode on it.
Oh, I see the method. Wait, that's genius.
Metal working, bro.
Yeah.
Then we cut out some screens to close the holes so no bugs or anything get in. For anyone who's worked with this aluminum HVAC tape, you know it's a pain in the to peel. We did both sides and started measuring the walls for the foam insulation.
Oh, dude. My bad.
It's not baby punching bag, bro.
After cutting them, we used some foam insulation glue stuff to secure it to the walls.
Yeah. I don't think this is. Fuck! I did it again.
We did this for like 4 hours. It took some time, but it started making the shed look really good. Once that was finished, we decided to put in the shiny insulation. This would help better reflect light and heat within the shed. And we worked until the sun set, finishing just in time. Just kidding, we decided to finish it the next day.
Good shit right here.
Yeah. Wait, what if you like twist it?
Ooh,
Get
yeah,
a
I don't have
big pop.
Let's go like this.
Yeah. Oh yeah. Oh.
But with all that finally done, this bad boy was looking like a mother heckin' spaceship. It was time to move on to the hardware. We got this Raspberry Pi with a heatsink case. But before coding all of that, we had to test all the Arduino stuff and make sure it was all good before designing a PCB. But here's a little time lapse of me trying to figure out how to put the case on anyway. But now it was Arduino time. I made some circuit diagrams on draw.io, and then we started wiring everything together on a breadboard to test it out. This is very important because you don't want any errors before designing your PCB, or else you spend a lot of time and some money for nothing. We used DHT22s for the temperature and humidity, which were better than our DHT11s that we used in the prototype. We also used capacitive soil moisture sensors instead of the resistive ones because those corrode. Then we had 2 4-module relays and 1 8-module relay for all the outputs, like the fans and heater and stuff. And lastly, we had a W5500 for Ethernet communication with the Raspberry Pi. we had to splice a bunch of extension cords for the relays so that they could control the outputs, but that wouldn't come into play until later. Now it was time for me to lock in and design the PCB. For those of you that don't know, PCB stands for printed circuit board. And this one, I have to admit, took me a lot of time to make. I had to measure each component to make sure they lined up on the PCB properly, and I also had to take precise measurements of the electrical box so I knew everything would fit properly. The entire team was hard at work every single time we met, and slowly but surely things began to come together. But there was still a long ways to go. I used KiCad to design this PCB, or KiCad or whatever, and yes, I also did use ChatGPT to assist me along the way. I decided to take a little break from that though and clean this old electrical box I got from a scrapyard. This would be the main housing for the PCB, Arduino, Raspberry Pi, and the important electronics. Oh, and we also did a quick power test just to make sure everything would work even when everything was on and powered in a worst case scenario. We knew all the voltages and wattages of everything, but we wanted to double check that it could handle everything in a worst case scenario, which it did perfectly fine. Then I got back to work on the PCB to finish off routing all the traces and everything so that it could be finished and we could order it up. Again, this took me a very long time to make, but it was super satisfying. I had to change some things around here and there, but it was worth it in the end. Finally, I finished the PCB and I ordered it up. And I have to admit, it looked pretty nice. While we waited for that to arrive, we started working on the electrical boxes, drilling holes in the sides for the conduit and wiring. After leaving a pretty big mess in the house, I had to clean it all up. Back at the shed, we began to install the intake and the outtake fans just using some nuts and bolts. Yeah, we twisted that shit up. God damn, strong boys. Okay. Then the PCB finally arrived. Here's a little unboxing for ya. And since it had finally arrived, that meant I had to get busy starting soldering all the pieces and components into it.
Hey.
I decided to just use a bunch of headers and pins so that we could unplug and plug stuff in as we needed to. And the boys worked on our tiny cooling unit. After I finished this, the real fun would begin, but I still had a little bit more to go. After a lot of time and concentration and breathing in a bunch of solder fumes, it was finally completed and it looked pretty nice. And then we were back to drilling more holes and getting all the boxes ready for installation. We put in our AC strip and we finished our makeshift cooling unit. And then we drilled some holes into our water reservoir for the pumps and wires. I started on coding the Arduino and the Raspberry Pi, but I won't bore you with that. We started mounting the rest of the electronics inside of the electrical box, and soon it would be ready to install them in the shed. We used command strips to secure everything, just so that everything was modular and could be replaced if needed. Then it was time to put in the grow light, and we took some measurements to make sure it would fit nicely. Then put some eye bolts in the ceiling to hang it from.
Skis, bro.
Finally, it was time to install the electrical boxes, which was a huge step, because then we could start installing everything else. So we took some measurements to make sure everything lined up and put them in.
Oh.
We used 3 electrical boxes for this project. One was for the AC power strip, one was for the Arduino and the Raspberry Pi and the control stuff, and the last one was for the relay outputs. Unfortunately, my hoodie suffered a little bit during this day. I made a shelf for the humidifier, dehumidifier, and the heater, and then we continued to work on the electrical box installation. Once all 3 boxes were in, we cut a hole through the back of the shed for the power cord to run through. Then we glued in some PVC conduit outlets, and I drilled another hole through the back of the main electrical box for the antenna to run through. Our shed was basically a giant Faraday cage, which meant no signals could get in or out. That meant the only way we could connect to the Raspberry Pi while the system was closed was connecting it through an external antenna. We installed the little shelf for the heater, humidifier, and dehumidifier, and next was installing the rest of the conduit inside of the shed for all the wires to run through. I then started putting in all the electronics, wiring the Ethernet cord, and putting in the camera. By this point, I had been coding for 2 weeks straight, and everything was ready to put in place.
She good?
James, you good?
Yeah, just fell off.
Yeah. It had been a very long journey, but the finish line was finally in sight. Pretty much all we had left to do was wire everything through the conduit as well as the sensors and make sure everything was working. Just like that, it was finally finished. We did a few small things off camera, but you'll see the finished result in just a minute. We wanted it to look nice, clean, and kind of aesthetic, so we gave it a bit of a paint job. Then I decided to put on the finishing touch with our letters, AGS. Might have not came out the greatest, but it gave it character. Lastly, this is our dashboard. This is how you control everything. This is in manual mode where you can set the temperature, humidity, and soil moistures, even the light timing on your own. It also displays all the current temperature and humidity too, and soil moistures. Next is test mode, where you can toggle the relays on and off to make sure all the connections are good. And last is auto mode, where our camera takes a picture of the plants, sends it through an API key, and identifies the plants to set the conditions in the shed. It's not 100% accurate, but I think it's pretty cool. Finally, it was time to test it on some actual plants. We tested this system on some microgreens, some mesclun, some cherry bell, and icicle short top radishes. We got some pretty good results too. The plants in the shed sprouted faster than our control group outside, and they also grew a bit faster than the other ones outside. Here are some pictures of our results. I won't bore you with the tables or data, but our shed definitely made a difference. It also pretty closely matched the set points inside the shed despite the heat or cold. Here's a quick graph showing the final weights after harvesting each of them. The microgreens gave us our best data and our most obvious results. As you can hopefully tell, this project took us a ton of time and effort. We worked really hard on it to make it as good as possible. I really hope y'all enjoyed this project as much as we did. Please leave a like and subscribe if you did. And with all that being said, I hope to see y'all in the next project. Jono signing off.